Nama saya Sarah Madiha binti Muhammad Liza, nombor metrik di 203-1107-837.
Nama saya Irtayu Farzatinisha binti Sumaili, bernombor metrik di 2023-1107-833.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Amir bin Mak Yasin dengan nombor metrik D2023-1107-839.
Assalamualaikum and hi, my name is Muhammad Nur Aiman bin Azhar and my matrix ID is D2023-1107790.
Hi, my name is Nurul Alnisha binti Alumti.
In this experiment, we investigate an electrochemical cell where the electrodes are identical but the ion concentration differ. These differences generates voltage due to the concentration gradient. Additionally, the potential difference at the interface of two solutions with different ion concentration, known as the liquid junction potential, will also be studied. These concepts are essential for understanding the behavior of electrochemical system and their practice applications. The purpose of this experiment is threefold. First, to determine the standard electrode potential of a silver electrode. Second, to calculate the activity of a 0.01 molar silver nitrate solution at room temperature. Lastly, third, to evaluate the liquid junction potential using a concentration cell and the transference number. This investigation provides a deeper understanding of electrochemical behavior and solution properties.
Now, let's continue with the procedure. For step 1, we need to prepare 3 solutions which are 100 ml or 0.1 molar argentum nitrate, 100 ml or 0.01 molar argentum nitrate, and 100 ml of saturated potassium nitrate. Next, to prepare 100 ml of saturated potassium nitrate, weigh 2 scoop spatula of saturated potassium nitrate and dissolve it with distilled water. For the solution, to 100 ml of volumetric glass. For part C, pour 25 ml of 0.1 molar argentum nitrate into boiling tube and insert a silver plate electrode into the solutions. Next, pour 25 ml of 0.01 molar argentum nitrate into another boiling tube and insert a silver plate electrode into the solutions. To connect the two half cells, use tube U filled with saturated potassium nitrate as the salt bridge. Connect both silver plate electron to a voltmeter using wires. For step 2, we need to prepare electrochemical cell. We have 4 different electrochemical cells. For part A, we take a boiling tube and pour 25 ml of 0.1 molar argentum nitrate solution into it. Insert a silver plate electron into the solution and ensuring it is properly connected to the circuit. Next, add 25 ml of saturated potassium chloride solution to another boiling tube. Place the calomel electrode into the solutions. The calomel electrode will serve as the reference electrode. To connect the two half cells, use a tube U filled with saturated potassium nitrate as the salt bridge. Immerse the ends of the salt bridge into the solutions in both half cells. The salt bridge maintains ionic continuity and reduce the liquid junction potential. Connect the silver electrode and calomel electrode to a voltmeter using wires. The voltmeter will measure the electromagnetic force of the system. Do the same procedure to part B with replace 0.1 molar argentum nitrate with 0.01 molar argentum nitrate. For part C, do the same procedure for part D with replace the tube U filled with 0.1 molar argentum nitrate. Please ensure to use fresh solutions for each electrochemical cell. Next, we continue with the errors and precautions. For errors, first error in preparing and measuring solutions lead to incorrect concentrations. Next, improperly salt bridge or uneven diffusions of ion through the bridge. Next, for precaution, first double check the calculations for solutions concentrations and avoid air bubble and ensure a proper connections between the two hub cells. Okay, this slide show the result for the experiment. The experimental value for this experiment, 550, is significantly lower than the theoretical value, which is 859.2. Possible causes of deviations is electrode contaminations or improper calibrations, the temperature fluctuations, or incomplete mixing. Resistance within the setup, effective voltage reading.
In conclusion, the electromotive force E cell of the various electrochemical cell was measured and compared within the theoretical values calculated by using the Nernst equation. Experimental values were observed to be lower than the theoretical prediction, likely due to the resistance within the experimental setup, electrode contamination, and temperature fluctuation or improper mixing. The experiment successfully demonstrated the relationship between ion concentration and the cell potential consistent with the principle of the Nernst equation. These findings highlight practical application in designing batteries and sensors for the medical diagnostic and also the environmental monitoring.